This is your Nexus 7018. If you want to zoom in here, if I say this is a 7018, means there will be 18 slots. If you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's actually 18. If I can rotate this a little bit, then I will be able to show you. Once I take it out, let's rotate this guy. See here, it's 18, 7018, 18 slots in here. Now, every Nexus device should have these two important components. The thing that we discussed was your control plane. What is the control plane used for? For example, if I have a device that I have EIGRP running, a routing protocol running. The routing protocol will talk to the other routers or switches, routing division, routing engine. So if there are two routers, they are talking to each other, they talk on the control plane. And if I have interfaces to forward data, they are my data plane. And there is also something called management plane, but in here, see this thing, this is your supervisor module. So there will be everything in a redundant fashion. If I say the brain, there will be two supervisors. IO modules, input output modules, there will be multiple.
The control plane and supervisor
is same. This supervisor is the control plane of this device. That is, and these devices are hot swappable. Now let me show you how to take this out. See, if I want, I can remove this Nexus 7K 2E. There are actually three versions, you can say. Supervisor version 1, supervisor version 2, and SUP 2E, supervisor 2E. Now it says that, see, there are many things on this supervisor. See, two supervisors, and we have embedded control plane packet. So if you want to capture the packets for the control plane, this supervisor also helps you. Now Nexus is based on virtualization, because you can virtualize this switch. First of all, see, if I tell you a little bit about that, first and foremost thing, that this device is built from grounds up by keeping virtualization in mind. So if I say I have this hardware, right? I have this hardware. On this hardware, I will have an operating system, this operating system, and this operating system is actually your Linux OS. On this Linux operating system, this will fire up NX OS, and on NX OS, then you will have your routing protocols. This is the actual architecture of your Nexus. Like your virtualization, we have guest OS, bare metal installations and all. So first we have the hardware. On this hardware, we have Linux OS, and this has the kickstart of Nexus. In this switch, there is a very nice feature called VDC. This is virtual device context. Now, if I say virtual device, means I can take out a part of this switch and virtualize this switch. I can create multiple logical switches inside one physical switch. For example, if I create this for one tenant of mine, and this I create another tenant, these two people will think that they are connected to their logical switches, physical switches. Actually, in the real sense, they are logical. They don't even know they are using the same architecture. Yes, we can connect them, but you need a physical cable to connect. Now, these are two physical devices. Actually, in real sense, actually they are logical, but for the tenant, it appears that it is one physical device to him. So I'll show you how to create. The moment you create a virtual device, you will understand that I am carving out my switch in two parts. How many parts you can create depending on your supervisor modules? You can either create 4 or you can either create 8. You can.
If you have 12 ports, you create a backup also.
You can do that. There are multiple reasons for that. But how many logical switches can you create inside a physical? You can have 4 or 8 depending on your supervisor. Virtual switches. See, if I say this is, yeah, this is my Nexus 7000 series switch. For example, if I say this is my Nexus 7018. Now 7018 means I have how many ports? If I say I am using 7000 series, 18 ports. I'll just put it inside. I have 18 slots, out of which 16 slots I can use for data forwarding, right? So if I have one slot that has at least 32 ports, for example, 32 into 16 like this. Let's take a small calculation. How many ports can I have? Calculator. 32 32 ports in one slot and 16 slots like this. I have 500 ports. Now, I don't want 500 ports for myself. I have a testing environment, or I want to lease out this switch to someone else. 500 ports, what I will do is I will simply give you 100 ports, for example. 100 ports given to you. How? I'll show you later on, but 100 ports for customer A, and 300 ports to customer B. Port number, for example, this is just layman term stuff. So 100 to 300 is for customer B. This is what I am talking about, is your virtualization in your Nexus. So virtualizing this switch is also possible. Now, if I say I have two separate customers, right? They will need VLANs, they will need their routing protocols. For example, if I say you can create 4,000 VLANs over here. Now, in a switch, you can only create 4,000 VLANs, 4094 to be precise. But if I virtualize this box, both these customers can create their own set of VLANs. Both these customers, see, if I say that this is my Nexus operating system switch, on this is my OS, this is my hardware, sorry. This is my hardware. On this hardware, I am creating my virtual switches like this. For example, this is my virtual switch number 1, virtual switch number 2, virtual switch number 3. All of these devices can run their own flavor of processes. Now inside also, he can run EIGRP, all these three people. He can say router EIGRP 1. He can say router EIGRP 1. This is totally separate, even from the control plane's perspective. I will show you how to do that. We will create two tenants. Both these tenants will be able to create the same VLAN number. This is virtualizing the switch using virtual device context, VDCs.
So supervisor failed.
No, there are two supervisors. If one supervisor fails, we have another for backup. See, this device is built grounds up from virtualization's point of view. See, I'll show you. If I say that there are two supervisors, there will be redundancy everywhere. See, there are supervisor 1 and sup 2, and the placement is also different. So this is my sup 1 and sup 2, both will be ready. One is active, one is standby. If one supervisor fails, another immediately takes action. Now, in your routers also, if you have a control plane that dies, nothing stops. If the supervisor also dies, the data is kept on forwarding. The data will not be stopped because data plane is separate, control plane is separate. Now, control plane, if you know MPLS, there is CEF, Cisco Express Forwarding. At that time, there is the table that is taken from the control plane to the data plane. So even if the controller is off, the data is still forwarded. Now, only the new things. For example, if there is a new route added, the control plane will take the route. He will do the calculation and put it down to the data plane. That is how it works. In here, if you say, I have only one supervisor, this soup fails, nothing will be happening. Only the new things will not be working. The old table will be consistent. Let us take out one module. Now, if you say, I want to, you see, there are two types of modules. Kindly note them down. One is M series line card, you can say. In 6500 series, you were able to have wireless. Here, you cannot do that. This is a pure data center switch. You can use it as a layer 3 device or a layer 2 device. If I say I want to use it as a layer 2, I need a layer 2 module. If I want to use it as a layer 3, I need a layer 3 module. So M module is more of, see, here it tells, if you want to run more of routing, you can use an M series module. So this is a modular chassis. See, 240 Gbps, 384 ports, P2P, layer 2, layer 3 features, max security, FEX devices, fabric extenders also supported. Later on, once we start implementing, it will be more clear for us. If I say I want to run more, see, this M module is more of a layer 3 module, you can say. If I want more of a layer 2 feature, I will use the F module. F3 is the latest one. Now, three important components. One is the supervisor. Another is the data plane. See, F series is now very important and the most famous part because it supports a lot of things. VXLAN, a very huge technology, data center interconnect, OTV. We will learn all these technologies. What is overlay? What is which one? It's kind of a same. It's at the end of the day, there is a tunneling mechanism, multicasting, ISIS, something the same. And now if I put this one inside, if I put this one inside, now this is on Cisco's website. Yeah, Cisco, I'll show you. Yes, see, this is your fan modules. That is in the recording, so you'll be able to see that. In here, now if you see over here, all the modules go straight inside. This supervisor goes straight, the data modules go straight, right? What connects them internally? There will be some internal wiring, right? The thing that connects them is your fabric module. Kindly note this down. This is the fabric module. This is also called as the crossbar fabric. Crossbar fabric. So your IO module and your supervisor are both going to be connected with this module called the fabric module. There can be 5. I will be able to show you this one. Fabric module. So we enter in our data center, and this is the one that connects both of them. See, if I show you outside over here, for example, this is my Nexus switch. On my Nexus switch, I will have my input output modules over here. So if I say this is my supervisor module, and this is my M module, for example, M module. How do they both talk to each other? How will they be connected internally? They will be connected using the crossbar fabric over here and over here, like this. This is your X bar or the fab module. That is what we are seeing. But the moment we go inside our DC, we will surely explore that. So how is your DC connected? On the backend side, there is this fab module. So if I show you this one over here, let's put this back inside. Fab module, insert. There will be at least 5 slots for fabric modules. See, this in the front end side is your input. Here you press your supervisor, and here you press your data modules. In the back end side, how are they connected? Here is your backplane Ethernet, you can say. Here is your, so the thing that connects your IO to your supervisor is your fabric module. And this is also redundant. The more FIs you have, the more speed in the communication. Virtual output queuing and all is there. See, all these devices, fan module, also hot swappable. You can take it outside when the device is running. Power supply, redundant power supplies. There should be 4, but you can work around. You can also take power from multiple vendors. You can also use there is a combination module. I can take power from 2 power suppliers, and I can keep one in standby, one in active. Or I can use both, because we use actually 3000 watts, for example. So I have 6000 watts coming in, I can share. That is inside. So there is a lot of, agility, you can say. Redundancy everywhere. It's very scalable. See, if you see here, this thing is, we will put our cables in here. Now, if you want to explore another device, maybe it is some other device for us. If this is your 7009 series. If I say 7009 and 10, these are your slots. How many slots it has? 7009 means it has 9 slots. 2 will be taken by supervisors. In your 7018, your supervisor placement was at 9 and 10, right? Here it may be different. Let's see that. This is our Cisco 7009 series. See here, it is a 9 series, 7009.
Sometimes modular, then the sometimes it's vertical there. So what governs that the module, this particular module will be say horizontal or vertical?
That is more device architecture, yes. Heating, ventilation, you have to see, yes. Previously it was like that, now it is like this. See here, if I say the supervisor, this crossbar fabric is over here. 1, 2, 3, 4, 5. It does not have the crossbar fabric on the back end side. See, if I remove the fab module from here, the fab module comes from the straight over here. So depending on your device, you have to be very cautious. Okay, where is my fab module? See, 550. The fabric module is on the back end side of 7018. In 7010, we see that this guy is on the front side. So for if you want to connect your supervisor to the data plane, The fab module is important, and 5 are there. So let's see. Yes. Let's go. And if you want to compare the modules, you can compare the modules from here. If you say what is the difference between all, if you say, see, there is compare modules, and all of these devices have Intel Xeon processors, quad core, dual core, Xeon processors. And if you say what is the speed, what is the memory on this, what is the flash, what is the CPU share? The thing that we were discussing previously was, if I use this supervisor next generation, how many virtual devices can I have? If you say I have a previous engine, older engine, I can have only 4 virtual switches created in that. If you have a new virtual, see, supervisor 1 and 2 kind of support both 4 plus 1, 4 and 4 plus 1. There is a history behind that. I'll tell you the difference between default and admin VDC. But just see, 1 and 2 both will support 4 VDCs. The new versions 2E will support 8 VDCs plus 1 for administration, plus 1 admin VDC. So there are questions which VDC, if we are for interviews, they will ask us, where is the placement of your supervisor module? So if I say 7018, which slot does the supervisor go? And how many VDCs can I create? Although creation of VDCs is just one-time task. Because once we implement a switch, we don't keep on re-implementing that. Once we create a virtual device, we just keep on running. Changing ports is our daily job, you can say. Not daily, but changing ports is what we will do is. And there is one component called connectivity management processor. If you remember in your 6500 series, there was this device. Now it is not supported on your new higher end devices. What is this CMP? This is a processor for you to manage this switch even if the switch is off. But nowadays it is not needed. CMP is not required now. See, now your F series is the one you should take care of. F series, latest one is F3 modules. This is a line card that we are talking, IO modules, line cards. And this has how much bandwidth? 600 Gbps, performance MPS and all. FEX support, yes. So if you buy a chassis like 7010 chassis, all the ports you have utilized. Now you want more ports. Instead of having more ports on that, you can simply take a 2000 series FEX and increase your ports over there. That is what we discussed previously, what your FEX is. So this is your M series. In here you have 48 ports. So if I say M1 will be the first generation, M2 should be the second generation, M3 third generation, 48. So in here, see SFP plus QSFPs, X2, RJ45. So if it is 1 Gbps port, RJ45 will be supported. If I go more beyond that, SFPs, QSFPs, so many devices. So let's see in here, VPC creation and all. Let's see whether my device has booted up. No, see if you see the first time installation, first time running up, you will see that this will call in Linux operating system. See, file system is 0x83, ext, Linux file system. Boot flash is running kickstart. So as previously discussed, it will fire up Linux first. Linux will call up the kickstart image of your NXOS, and then it will call up your, see, there is something called control plane policing by default that is enabled over here. Let's go more inside this one. See, VDC1 has come online. So let's see in here. This here is asking me for a question. This is saying that should I go ahead and abort? So it says abort power on auto provisioning. So we don't have any DevOps team that is working on this one. So I will say yes, abort. So if you are over here also, you will say abort this auto provisioning. And because we don't have a script that is running, right? So we will abort this and we will come on this prompt. So initial setup, it says, do you want to have a strong password? I can say yes to it. If I say yes, what are the basic parameters? Capital letters, small letters, alphanumeric, special characters. But I say no, I will give it a password that I want. So here it is asking me to enable an admin VDC. I will say yes to it. Now, for example, if I want to enable, I will say yes. If by mistake I said I don't want this concept of admin VDC. Now, what will this admin VDC do? If I have a switch over here, For example, I have a switch over here, and this switch will have at least one place that has all the interfaces over here, right? Now, in here, this will be an ID of 0. This VDC will be ID 0. And this is where all the interfaces will be there. So if I say, I do not want to use an admin VDC, the thing that we said will give me all the ports inside. For example, if I say, I have at least 100 ports in here, all these 100 ports will be available for me to use. I am not enabling admin VDC means this is a working switch. I don't want anything to be done. Now, if you say later on, I want to manage this switch, I want to lease out this switch to someone, then we will have to create a different VDC, different virtual device. So if you say I add in port number 101 till 200, I add in 200 more ports, just in layman terms. Now I don't want to use these and I want those people to use this. At that time, you will create another VDC. You will say, okay, create a VDC for my tenant 1 or 2, for example, and allow, or create another VDC for my lab people. So these lab people will be using the same switch, but they won't even come to know that they are using a switch that is, they are sitting on my same box, because these two devices will have separate control plane, separate data plane. They can run their EIGRP, no problem, EIGRP, autonomous system 1, and I will be able to use EIGRP autonomous system 1. Routing table is totally separate. Let us see, I'll show you this one. So what happens if I go in here and I say, I don't want to use the basic configuration setup, and here this is admin, my password, show VDC membership. Show VDC membership will tell me, see, this will be visible. There is a VDC ID 0 and VDC ID 1. Actually, this was supposed to be the admin, but I did not configure admin VDC, so I have all the interfaces. I am free to run all the routing protocols, everything. 0, no, because see, if I say I want to enable an admin VDC, then all the interfaces will go back in here, because admin VDC will never have an interface. But I said, I don't want that feature. I want simplicity. This is my device. I don't want to share it maybe. Now what we will do is, I will show you the difference. Let's go ahead. Now see, you see VDC ID 1 has all the interfaces, right? Now if I say system admin VDC. Now later on my manager said, I want to lease out this box. So I need a control place. So this will go ahead and create an admin VDC. Now see the difference, what happens. I will be, now all the interfaces will go to unallocated, and admin will not have one single interface. See what happens over here is, it is doing, or see, and it told us that all the configuration will be wiped out and those interfaces will be gone. Show VDC membership. Here, see what happened here. ID 0, unallocated interfaces, means this VDC will not be capable of having one single port. Now this becomes our administrative point. I will be creating another VDC. Now what is the architecture? Now there are all the interfaces, but all these interfaces are gone. Now this is a switch, but without any ports. There is not even a single port. So I cannot do anything over here as of now, because there are no ports. Where are the ports? The ports are sitting behind over here that are unallocated. Now the task is, you have to create a logical switch, a logical virtual switch, and give him 10 interfaces, for example, so that this switch has interfaces. How will you do that? Yes. Now what we will do is, I will create one VDC over here. Now, but where will I go inside? I should be in the admin VDC to create a virtual device over here. How do you do that? Let's say, now I will be in the global configuration mode, and I will say VDC space VDC1. This is the name of that VDC. Where am I? I am in the admin VDC, I am creating a VDC called VDC1. This is a virtual device context. Now I created a VDC ID1. Now I have a few modules. I have my third slot has some ports and the fourth slot may be having some ports. Let us see. If I go in here and I say show module. Now a very good thing about Nexus is show commands will run everywhere. No need to say do. See here it says that you have first is your supervisor module. That is the 7K sup2 and this is active. And there is a third slot. So in my third slot, I have 32 ports. That can be 1 to 10 GB. So if I say 3/1, I am talking about the third IO module and this is the first port inside this one. And this is my F series, first generation 32 ports. And second is M. So if you want to run anything related to layer 2, you can say you can run on 3/. If you want to assign an IP address, you cannot assign it on layer 2 switch, right? So layer 3 M module, you will assign an IP address. So here I want to give that VDC 10 ports. For example, I have 32 ports. I will give that VDC. See, this is my fabric module, fab module 2, fab 2, and this is 7009 series chassis. So where am I? I am in the admin VDC. You can also type where and you can say, okay, this is my admin VDC and I am configuring the VDC1. Now, the second command will be to allocate interface. I have created this switch over here. I want to put certain ports inside this one, right? Now, what will be the commands? It will be allocate interface E3/1-10. Just a moment. Let's say yes to this one. And what am I doing now? I am giving it 10 interface. So I created a switch. I gave him 10 interfaces. Now I want to check. I can check by show VDC membership. And here it will tell me, see, it starts with 3/11. Means unallocated does not have those interfaces. This guy will never have any interface. And this is a tenant of mine. Let it be any name. And it has 10 interfaces over here. Now you created a virtual switch. You have to go inside that virtual switch. You cannot do anything over here. Now the other command will be switch to VDC. Let's say switch to VDC. I want to go inside that switch. Where am I now? I am inside this switch. I am sitting in here. Now I am inside a well, you can say. Inside a well, I cannot go see outside. See, you have logged in on a switch. See, and it is asking you to do the initial setup. Now this is a switch. I am just testing whether my tenant will see this environment. One second, hold on. So let's see, where am I now? It will tell you this is a switch and this is a VDC ID1. We are inside that switch now. See here, you can easily come to know that this is a VDC inside a switch, right? But I don't want this tenant to understand also. So what can I do is, I can go back. If I say exit, I can say no VDC combined hostname. VDC combined hostname. By doing this, my tenant will not even come to know that he is using someone else's shared box. For example, if I come out and I say switch to VDC1, see now what happens is, you have a switch and you don't even know that you are using a shared switch. I will say show interface brief. And this guy only sees only 10 interfaces. He is using a Nexus device with 10 ports only. All these ports have a different speed, you can say. So now I have a switch that has 10 ports. Let us say exit, and you can also say switch back. Switch back is for administrators. We are going back into the main VDC over here. So switch to and give the VDC's name and switch back. So if you notice what are the commands you have seen.